All right, so as we move through chapter 4, our goal today is to be able to understand, explain, and compare 3 different types of sampling approaches. So stratified, cluster, and systematic. So as you work through this lesson in these notes, I want you to be thinking about both sampling processes. And when I say both, is we're focusing mostly on stratified and cluster. They both use an SRS, so that simple random sample. I want you to compare how they differ with respect to the use of the SRS. So as we talk through the stratified and cluster, they're both using a simple random sample technique at some point, but they're using it differently. So I want you to be paying attention to when does each use the simple random sample in their process. So by the end of this lesson, you should be able to take these 6 scenarios and be able to pick out which sampling method is being used. If it's a convenient sample, a voluntary response, a simple random sample, stratified, cluster, or multi-stage. All right, so just to get us thinking, in order to understand the opinions of students at Austin East about the courses offered, Ms. Glover decided to survey the students. So I have 3 different scenarios of how she approached choosing her sample to represent the population of Austin East students. So first, she divided the students by lunch, so she divided them by some common characteristic, and then she randomly chose to survey all the students from the first lunch. So there was a random selection of which lunch to survey all the students. Second, she divided the students by grade level. So she divided them up by a common characteristic. So very similar to this, only this is a characteristic and this is more of a location, all the students in one area at one time. Then she did a simple random sample to choose 45 students from each grade level for a total of 180 students surveyed. So in this case, her simple random sample is to choose from those common characteristic bands of grade level. And then lastly, she numbered the students in the school and then chose every 7th student to survey. So I want you to just take a minute and think about what's the strength of each of those scenarios, because we're not falling into the bias of convenience or voluntary. And then what might be a drawback of each of those, because these 3 are all considered better sampling practices than the voluntary and the convenient sampling. Now, they do have some drawbacks, but I want you to think about what could be a strength and what is a drawback of each. So for this section, we only have 3 vocab words that we're going to be talking about that are new. So cluster sample, stratified sample, and systematic sample. So be listening for those as we work through this lesson. All right, so a cluster sample. A cluster sample divides the population into clusters or groups that are near each other. So in the previous example with Ms. Glover, the example where she divided by lunch. So everybody's near each other in the different lunches. You choose some of the clusters by simple random sample. So in that case, she did a simple random sample to choose the cluster to survey. And then the biggest thing is you need to look for all the individuals in that chosen cluster is being sampled. So she interviewed every single person in that lunch. So the simple random sample happens first to decide which cluster or clusters I'm going to use, and then every single person from that cluster is being selected. So if you look over here, there's a visual over here to the right. So what I've done is I've taken each of these dots represents an individual, and so we've grouped them by location. And so there's 6 different locations. And then we did a simple random sample to select cluster 1 and cluster 5, let's say. And then I survey all the members of that cluster. This is another kind of visual of it, is I'm clustering by their location. So these people are on 1st Avenue, these are on 2nd Avenue, and these people are on 3rd Avenue. I did a random sample and I decided to choose 3rd Avenue and I survey each person that's in that location. So a cluster sample is a sampling process where the population is divided into groups that are located near each other. So that's this part up here. And an SRS of the cluster is chosen, and all individuals in the chosen cluster are included in the sample. So that's the big keyword you're looking for, is if I'm surveying all the people of the group that's been chosen, that is a cluster sample. So these are some examples of a cluster sample happening. So in this first example, the population is all people in the U.S. So I'm trying to learn about all the people who live in the U.S. So I'm going to divide into groups or clusters by location. So the time zones give us a nice, easy way to divide the population. So obtain a simple random sample. So there's 4 time zones, and I do a simple random sample, and I choose 2 of the 4 time zones, and then the sample comes from every person in the 2 selected time zones being surveyed or experimented or whatever. Now that's not very realistic because it's kind of like surveying the population, but that would be an example where I choose my clusters through a simple random sample, and then every single person that's in that specific cluster is going to be surveyed. Another example, so all PSU, so Portland State intercollegiate athletes, so all of the student athletes at that university, so I'm going to divide them into clusters, so by team. That's an easy way that they're divided into already naturally occurring locations. And so I do a simple random sample, and I choose 8 teams. So each one of those teams has an even amount of chance of being selected. And then from those teams, those 8 that I choose, I survey every single athlete on that team. So I'm choosing the cluster by a simple random sample, but then everybody within that cluster is being selected. The other example is all elementary students in a school district. So a natural cluster would be students who are at different elementary schools. So those would be my clusters. And so I do a simple random sample to choose 4 of them, and then I survey every student at one of the selected cluster elementary schools. So, and the advantage of this is that people are naturally grouped together. So it's a lot easier to go to 4 different elementary schools and survey all of the kids. However, a drawback is what if my simple random sample selects 4 elementary schools from the same region? So if I chose 4 out west elementary schools, are those going to represent the population? Now, they were randomly selected which school I went to or which cluster. So there's that random selection of the clusters hopefully combats the bias that could exist. But at the end of the day, there's still a chance that I could select all of them. So the cluster sampling is better than a voluntary or convenience. It's more practical than just a simple random sample of the whole population. And it gives me the advantage that people are already naturally clustered by location. But a drawback is that my sample might not represent the whole population. So things that serve well as clusters would be like schools, city blocks, counties, states, just anywhere people are naturally geographically close to each other. So here are some pros and cons. We kind of already talked about this. So a pro of cluster sampling is it saves time and it saves money. So instead of interviewing every single person from across the United States, I can choose different areas by random selection and go and interview or survey all those people. It's more convenient while still providing a good sampling method. So I'm still using random selection, which is what we want because that gives us a better chance of reducing bias, and it's more convenient because the people that I'm choosing are in one natural location. However, a con is that it doesn't always represent all the members of the population. So I want you to pause the video and think about why might it not represent all members of the population? Why might this process of dividing people by location and then simple random sample, choosing the clusters I'm going to use, and then surveying all members of that cluster, why might that not always represent the members of the population? All right, so go ahead and pause the video. That is our first part of our objective, is to understand, explain, and compare cluster sampling. So what questions you have, what visual might help you remember this one, and what is the key characteristics that we talked about that made a cluster sample a cluster sample. All right, so stratified sample is a similar concept, but we're going to use the simple random sample a little bit differently. So a stratified sample is a sample that divides the population into strata, so groups that are similar in characteristics. So it's not necessarily that they're similar in location, but they're similar in characteristic. So over here, these are my different strata that I've divided these by, maybe this is by job. So your type of job that you have, you're divided into these different groups. And then I do a simple random sample of members from each strata. So instead of surveying all members in my chosen group, I'm surveying one or 2 or 3 or however many from each group. So in a stratified sample, every group has representation. This is another visual. So these people have been characterized by some sort of characteristic, and I do a simple random sample to choose one person from each group. So the advantage is that I do have representation of the population. Every group has representation, but a drawback of that is that's going to be very time consuming. So if we were thinking about the time zones or the elementary schools, I'm going to have to go to every single elementary school and grab a few kids from there, versus the cluster sample provides me with, I'm going to just certain locations. So a stratified sample is going to produce a stronger sample that looks like your population, but it's going to be a little more time consuming and costly if we're talking large scale sampling process. So just here are some examples. Same situation. Here's my population. So people in the United States, all Portland State University intercollegiate athletes, or all elementary school students. Those are my populations. I'm still dividing them into that same strata. Now, clusters and strata, cluster is more of a geographical location or some sort of easy way to find those people, and a strata is more of a characteristic. In this case, they're showing that the strata and the clusters are similar. So when I think about strata, it's a characteristic that all those people have. So we still have everybody who is on the basketball team still has the characteristic of being a basketball team member. So that can be a little confusing with this example, but I like that it showed the different way of using the same situations. Okay, so to obtain a simple random sample, instead of doing a simple random sample to choose 1 or 2 of the clusters and survey all of them, I am choosing 500 people from each of the 4 time zones using simple random samples. So every single person is assigned a number, and I'm using the technology to decide who I'm going to survey. Here, I'm choosing 5 athletes from each of the teams. So in the previous example, I only interviewed 8 different teams, all the members of 8 different teams. Well, if the 8 different teams are the basketball team, the men's and women's basketball team, the volleyball team, the track team, and whatever, and nobody's being represented from the golf team or the football team, their opinions aren't going to be counted, and they might have a valid opinion. Whereas here, my simple random sample is I'm choosing 5 from each team. So my sample makes up at least 5 members from every single group in the population. And then in this case, the 11 different elementary schools, I'm going to choose 20 students at random from each of the 11 schools. So every school from representation, and that's the thing with a stratified sample. My simple random sample is how I'm choosing from each from each strata, but every strata has representation. All right, so a stratified sample, the pros, each subgroup has representation, and that's really important because we want our sample to look like our population. And so in that case, we're more guaranteed that our sample is going to look like the population because each group has representation. Specifically, small subgroups are better represented. So especially when we're talking about if I were surveying all of the collegiate teams and asking if they felt well funded, probably the football team and the basketball teams, because they attract more fans, are going to say yes, versus the golf team where they have to drive themselves to their meets. Those smaller subgroups, because a golf team is going to have less representation than a football team, they're going to be better represented because they're guaranteed that representation. The cons we talked about, it's more costly and it's more time consuming because I have to go to all of those locations, and so that's going to cost more money and take more time, especially if we're talking about a large scale sampling. All right, so you can understand, explain, and compare stratified and cluster. Now we've talked about the two. So go ahead and write down any questions that you have. What are you going to need to remember? What visual might help you remember how the stratified sample takes place? We've already talked a little bit about the systematic, but I wanted to make sure that we talked explicitly about it. So systematic is a sampling structure where the population is numbered. And so if we're talking about a large group, there's going to be a start and stop point in that numbering that you're going to use. So you're not going to number all 17 million people, billion people, however many people live in the United States or in the world. You're not going to number all of them. You're going to maybe choose a certain stop and start point, which is a drawback of stratified, is if I'm doing large group, this isn't very realistic. And then I choose every nth individual is chosen to complete the sample. So in this visual, so every single person is numbered, and I'm choosing every third person. So 1, 2, 3, you're in the sample. 1, 2, 3, you're in the sample. 1, 2, 3, you're in the sample. So is this a simple random sample? It's not, because by definition, a simple random sample means that every individual has an equal chance of being selected. So if I number all of my students based on their last name, because this person's last name starts with an A, they already are ruled out. So they do not have the same opportunity of being selected because of where they are positioned in the list based off some characteristic. If we went shortest to tallest, the shortest person automatically is not going to be ever selected. So systematic is better than convenience, it's better than voluntary, it's better those other biased creating sampling structures. However, this still isn't the best, but it's better than the alternatives. So some pros is it's simpler, it's convenient, and it's less costly. Cons, like we said, it's not an SRS, so not every member of the population has an equal chance of being selected. All right, so go ahead and pause the video, and now you can understand, compare, and explain systematic samples. So draw a picture, write down any questions you have. What are you going to need to remember about a systematic sampling structure? All right, so this looks like a lot, but this is going to help you, because one of the hardest times that my students had last year was being able to look at a scenario and decide what type of sampling structure it was. So I just kind of went through some guiding questions that helped me determine what it is. So the first question I'm going to ask myself is the population divided into groups? So if the answer is no, then it's probably going to be one of these. So a simple random sample, a volunteer survey, or a convenience sample. So is the population divided into groups? If I said yes, what are the two that we talked about dividing into groups? Cluster and stratified. So if the answer is yes, then it's probably one of those two. So then the next question I'm going to ask is, are all groups represented in the final sample? So when I think about cluster, I did a simple random sample to choose the groups, and then I interviewed all the people from just those groups I chose, versus stratified, where I did a simple random sample to choose people from each group to make up my sample. So are all the groups represented? If the answer is no, it's probably a cluster sample, because I'm only interviewing people from the chosen groups. If it's yes, then it's probably a stratified sample. So if the population is divided into groups and every group has representation, it's probably stratified. If it's divided into groups and not every group has representation, it's probably cluster. Are all the members of the group being sampled? And that goes back to, if I choose the group and every single person is being surveyed, it's probably a cluster sample. So if I say yes to that, it's probably a cluster sample. Is an SRS being taken to determine the groups that are surveyed? So the simple random sample is being used to pick the group, that's a cluster, versus the SRS is choosing the members of the group to be surveyed. So who from each group is being surveyed, then that's a stratified sample. So hopefully this helps you kind of process through some questions you can ask yourself as you're reading the context, looking for those keywords or key phrases that will help you determine which type of sampling it is. As always, I like to give you the vocabulary with, my dog is barking, I'm sorry. But here are the definitions with the vocabulary words just for you to have, and I will see you tomorrow.